Hello everyone, I am Sanchita Tambe, an intern in Emertxe Information Technology, and I am going to present you the final presentation of my internship along with a microwave oven embedded system project demonstration. So below is all my information. Now let's get started. Throughout the internship, these are the topics which were covered. We were given the in-depth understanding of embedded C programming language along with the PIC microcontroller with its interface facing with different various peripherals, and finally we created our own microwave oven simulation as an embedded system. So before explaining the working of the project, I am going to explain some concepts which will be useful, which was useful in my coding. So first is interrupt service routine. So what exactly is an interrupt? Interrupt is like an interruption to the normal working of the microcontroller. So there are mainly two types of interrupt: external interrupt and internal interrupt. The internal interrupt are interrupts occurring inside the microcontroller. For example, one of the main interrupts which we are going to focus on is the timer interrupt. Whenever the final count of the timer is reached, it creates an overflow. It sets the overflow flag which causes the interrupt, and that interrupt is useful in programming, which we will see later. And external interrupt is caused by the external peripherals connected to the microcontroller. And interrupt service routine is a program, is a routine. Basically, routine as in a function which is stored in the memory, which defines what the microcontroller should do if a specific interrupt is encountered by it. Sourcing and syncing circuit. So this was a concept explained to us during internship. So I am going to give a brief idea about it. So as you can see from the diagram, the syncing circuit is something where our main element is actually consuming the current from a source, and in the sourcing circuit below, our element is actually the source of current for the resistor. So that's the basic difference between sourcing and syncing circuit. Timers are used in our project, that's why I'm going to give a small, as you can see from this table, there are three timers: timer 0, timer 1 and timer 2. In our project, timer 2 is used, and there is a specific register to control it, and the count register which actually stores the count of the timer. Now I am going to explain the working of the timer through this block diagram. As you can see, every microcontroller has an oscillator which generates the clock pulses, and then this clock pulses goes to the pre-scaler where it is scaled as in it is the speed of clock pulse is reduced according to the actual seconds, so that it counts the actual seconds. And as the timer is enabled, the count keeps on increasing till it reaches the final count, that is the FF. And after it reaches the final count, the overflow flag is set, which generates the interrupt at the end. And through this interrupt, The interrupt service routine, it can be programmed, which can be useful to understand that the timer is finally set off. So now we are going in depth about the project. So as I said, we are going to simulate the microwave oven. So we need to understand what are the modes which we are going to simulate as an embedded system. So there are three modes. First is the microwave mode, which has the power of 900 watts, and it utilizes the magnetron generated microwaves to excite the water molecules present inside the food, which causes rapid vibration, and that generates a lot of heat. So it is essentially used to generate a lot of heat at a small amount of time. And second is the grill mode, which is similar to microwave mode with less power, and it is used to heat the protein and the bread based items. And the convection mode is something which has a preheating option before the actual microwave cooking. So it has the starting preheating mode, which is for 3 minutes, and then the actual microwave mode, whose timer will be decided by us. So this is the working of a microwave oven. As you can see, there is a magnetron tube which generates the radiation, and the mode steerer is actually the system which defines what mode the microwave oven will work. So the changes in mode steerer is actually responsible for different modes. So the features of the PIC microcontroller which we are going to use, this microcontroller is a brain of our whole embedded system. So these are the features. Some of the main features which I need to talk about is the high performance RISC CPU. So what is RISC? RISC is reduced instruction set computer, which means the instructions required for the microcontroller is very simplified, but the architecture is complex. So that is essentially the definition of reduced instruction set computer. And it has the Harvard architecture, which means that there are separate registers for the data and for the code, and the different buses for the same. And it has, as I mentioned in the table, it has 2 8-bit timers and 1 16-bit timer, 2 PWM channel pulse width modulation. It has an operating voltage of 2 volt to 5.5 volt, and there are 33 IO pins. I am going to show the configuration in the later slides. It also has an 8-channel 10-bit analog to digital converter. So this is the architecture of PIC microcontroller. As you can see, there are multiple IO ports, A0 to A7, where A0 is the LSB, A0 is the MSB, and A7 is the LSB. And these are the ports which can be used as input and output. There is this address multiplexer. As the pins of the PIC microcontroller have multiple operations, which means that one pin has multiplexed operation, like there is multiplexing of address and data buses and different operations. That's why this multiplexer is required to separate it out. There is an instruction decode and control, which decodes the instructions received by the microcontroller, there is the register which stores this decoded instructions. Working registers which store the data which the microcontroller is currently working on. Working on as in there are various arithmetic and logical operations which are performed on data, and these data is stored in the working register. And status registers are basically the flags. For example, as I explained earlier, the overflow flag, and there are various flags. And as you can see above, there is the data bus. And program counter is a register which stores the address of the current instruction. No, it stores the address of the next instruction while the current instruction is executed. So this is the architecture of PIC microcontroller, and this is the microcontroller which we are going to use in our project. So now we are going on to the peripherals which will be interfaced with our microcontroller. First peripheral is the LCD, liquid crystal display. This is the 16:2 LCD. In our project we are using 16:4. Then there is not much difference in the pin, just the size. So I am going to explain the 16:2 one. As you can see from the table, the main pin I want to focus on is the RS pin. So LCD has two registers. One is the command register, and another is the data register. So what this RS pin does is that if this RS pin is set to 0, then the command register is selected, and whatever data we give in this data pins will go to the command register. And if RS pin is set, that is it is in 1 logic high, then whatever data we give in these data pins will go to the data register. So it is used to this RS pin is used to define in which register the data should go, and R/W pin should be 0 if we are actually inputting the data in the data. If we are output R/W pin should be 0 if we are outputting the data in the data pin, and R/W pin should be 1 if we are inputting the data in the data pin. And enable is the pin to enable the LCD. It should be high if you want to enable the LCD. And these are the data pins, where DB0 is the MSB and DB7 is the LSB. So next peripheral is the 4x4 matrix keypad. So this is the configuration of the 4x4 matrix keypad. If, for example, one key is pressed, suppose the top left key is pressed, that is the 1. So what will happen if all the R1 to R4 and C1 to C4 pins are high? So what will happen if we press this? C1 and R1 will get connected, and there will be output low in both the pins, which can be detected by microcontroller, and accordingly program can be written to detect that the one key is pressed. So this will be used in our project. That's why understanding it is essential. So software used in our project is Fixing Lab. It is a simulator which simulates the actual PIC microcontroller with the interfaces which were explained earlier. MPLABX IDE is the integrated development environment where actual code was written and then the hex file was created using the XC8 compiler. So these are the snapshots of the project. You can see this is the mode select option displayed in the LCD display. This is the micro mode where the timer was set by us and the timer is running with the options of stopping and pausing as well as resuming. This is the convection mode where we set the temperature and the food can be cooked to a specific temperature along with the preheating option before cooking. So I am going to demonstrate project after this, but that's the end of the presentation. Thank you.
Hello, now I am going to demonstrate the working of the actual microwave oven project. So this is the Pixim Lab interface. I have already loaded the program through this load hex option. As you can see, the microwave oven is starting right now. This is the opening interface where we have three options: micro mode, grill mode and convection mode. The start mode is the default option whenever the user doesn't know what to do, like she has to just heat the food, so they can use the start mode, and for specific requirement the three modes are defined. So let's start with the micro mode. So the power of this is 900 watts as explained in the PPT. We define the time for which the mode should be running. So for the demonstration I am going to set it as 10 seconds using the 4x4 matrix keypad, and I am going to click enter. So as you can see, the microwave is the simulation of microwave running is demonstrated through this fan, and the timer is working properly as expected. So the cooking is done and we have been alerted accordingly. So the next mode we are going to simulate is the grill mode. Let's select the second option. So again we have the interface to set the time. Again I am setting it to 10 seconds. So again the cooking is being done and the fan is rotating. That's it, the cooking is done. So on to the next mode, it's the convection mode. In convection mode there is an additional option of preheating the food before it gets cooked. So we are going to select that option. We also have the option to set the temperature in which the food needs to be cooked. This is the special setting in the convection mode. So I am going to set as 100 degrees Celsius and then I am going to select enter. So as you can see, the preheating is being done right now, and after preheating the normal options which we can see in the previous modes will be displayed. For example, the time for which it needs to cook. So this is an additional special option in convection mode. It might take time. It will take time. So I'm going to skip the part. I have resetted the system, and again we will see the four options. And I'm going to now demonstrate the last option in the system, that is the start mode.
So the start mode, you can say, is the general purpose, or the, you can say, an easy mode for the user. Let's select the start mode. You can see we don't have to set the time, it is already defined, and the food is been cooked using, it is simulated through this rotating fan. Meanwhile, as the food is being cooked, you can easily see that 16:4 LCD display is used to show the operations occurring in the microwave, and the 4:4 matrix keypad is used to select options conveniently by the user. And all these components are explained in the PPT. You can also see the PIC microcontroller here, which is actually the brain of this whole process is happening here. So time is over and we get the alert of cooking time up and food is been cooked. Thank you for watching the video. Thank you for watching the presentation. Have a good day.